Good morning, everybody.
Good morning.
Good morning.
Yeah. So today is October. Someone. Can you please mute yourself? Okay, thank you. So let us start our lecture today. Today is October 5th. Give me 1 second. Okay, there are a few announcements at the beginning. So first of all, so there is a good news that you will get our GTA for in-person office hour. So I just posted an announcement in D12. Please see the more information. See more information about GTA office hours. Okay, and please do not feel hesitate to go to any GTA that is not in your section. So our GTAs from one section, from any section, can help to student of any section. Okay. Okay, so your test one is grading is completed. This morning I wanted to publish the grades, but D2L was down, so it was down after 9:30. So now I see that I'm lucky that it is now up. So I post test on grade this afternoon. Okay, and then when you review your grade, if you have any questions, please email me. Okay, and okay, so let us see our schedule first. So according to our schedules, this week we will discuss QE. Okay, and so quiz 3 and assignment 4 are due. Were supposed to be due last week, but I have extended it until October 10th. So assignment 1 will be due. Let us see. Assignment 1 is due, is scheduled to be due October 8, but the extended date, extended deadline will be October October 10th. That will be extended, but please do it, complete it. Okay, let me make it October 10. Let me make it October 10. Okay. So assignment 4 is due October 10th, and quiz 3, that is up and that is due in October 10th, by this weekend. So quiz 3 and assignment 4, please do it, okay, by this weekend. No, assignment 4. Okay, so after that, okay, that's good. After that, we have we have some relax in quiz 4 and assignment 5 upcoming weeks. Okay, so according to our schedule, so this week we'll discuss QE. So in our last lecture, we discussed stack, and stack has, as you noticed, that stack has many operations and many use in computer programming, in computer science. We call stack is a fast data memory space. So I conducted 2 lectures. So we discussed stack, and then in the previous lecture, the lecture before the last lecture, we discussed prefix notation and postfix notation. There is a good term. It's called police notation. There's a mathematician in Poland, according to his name, that is called police notation. Yeah, please practice this example, and in your test you will get similar kind of examples, not exactly from the book, but you will get similar kind of example, okay, in your test. Not that one. This one is postfix notation. Okay, postfix notation, that means all operators go at the end. So this is postfix notation. That means these are 2 operand, and this plus it goes after these 2 operand. That means we know that plus operator, it takes 2 operand, one on the left side and another on the right side. So this 2 will go left side, and then the right side the plus, so then 2 plus 3, 5, and then 5, and then there will be the next line, there will be 5 space 7 space star. That means star will be the operator for 5 and 7. Okay, that means 5 times 7, 35. Okay, so please practice this. The the pseudocode is simple. The pseudocode is simple. In the test, you will get this kind of example. So it is called postfix notation. Okay, and then there is another one that is called prefix notation. Please practice both. Okay, and usually in regular mathematics or algebra, in regular calculation, we use infix notation, and that means the operators take place inside the operand in most of the cases, like 2 plus 3. But for some cases it takes prefix. For instance, -5. Yeah. So that negative sign for unary operator that takes only 1 operand, it always takes prefix notation. Okay, so please practice this kind of in the book. Please, first of all, please practice this one from the book, and when you understand this, then there are some examples from the book, exercises from the book. Please practice this. Okay. Okay, now let us start our new chapter, QE. So as I discussed, stack, SKU is different. Stack is it's called last in first out, LIFO type data structure, but QE is in first out. That means QE, so this is stack on the left side and this is Q on the right side. QE, it has front and rear, front and back, or front and rear. at top or bottom, and data enters, item enters, and item enters from the rear and it goes out through the front. But in stack, there is only one side open, so all operations, input and output operations, happen on top. So QE is called a FIFO, fast in fast out type data structure. In our daily life, we maintain QE when we go for shopping in order to go to the cashier. In checkout station, we follow a line. Okay, that is a kind of QE. When you get in bus, okay, or a train, we follow QE line. So, like most of the programming languages, modern programming languages, C++ has a built-in QE. Okay, but in addition to that QE, we will see how to develop a QE. So in QE, there are only few operations, actually 3 operations. This is called NQ and DQ. What are this? What is this? Is pop, push and pop are for stack operation. Why they called QE? In standard, why they mean? Why they call push and pop? So in modern technology, it's this terminology. It's called NQ and DQ. Why they put push? They use QE. Actually, this should be NQ and this should be DQ. I'm coming this one, okay? I'm coming an example. So QE has some application, useful application in computer programming. One of the common application is known as palindromic string operations. For instance, to check whether a string is palindromic. Palindromic means if you are given a string, no matter how large or small it is, in general, except it's not a single letter string, not a single character, more than 2 characters usually. So if you reverse it, okay, and then if you find the same thing, then it is called a palindromic string. For instance, here this string, we see that this string Abel was I saw Elva. So if you okay just, if you reverse this string like in opposite direction, so then but A B L E Abel, but here it should be in uppercase, and then if it is SAW, so then Abel was I saw ELBA. That is same thing, right? So if you read a string from left to right or right to left, then it will be something. You know that there are some languages, in human languages in this world, there are read from right to left, like Arabic language. in Persian language. They read from right to left. And English, standard English, we read and write from left to right. But there are some other languages, they read from top to bottom or bottom up, like Chinese language or Japanese language. It's okay. So one of the application of QE is that to read a string in reverse order and to match, okay, whether the string is same, exactly same character by character, even including space, even in from left to right or right to left. So if string has that criteria, then that is called palindromic string. So here, this is a program. Okay, this is a program. It uses, okay, both stack and QE. Okay, they uses built-in. So in QE, then standard library, as I said, there is a built-in stack and built-in QE. So that in order to use the stack, you need to use stack header file, include header file, and in order to use the QE, you need to include stack QE header file. So this is a QE. So in programming, you will see like this kind, this character with an angle bracket. That means this QE is restricted with character type. It will not take any other data except character. Okay. So this one. Yeah. Okay. Small program. Let us try this one. How did I put my name? Okay, so let us try to run this one. Okay, let us try to run this. Okay, so it is asking me enter a line, and I will see if it is a palindrome. Okay, so if I write a line A B L E, A B B A. Okay. So this string A B B A, if you read in reverse order or opposite order, this will come same. So this is palindromic. Okay, if we run this program again, and if we put another number, for instance A B C, another string, so this is not a palindromic. Okay, so I'm sharing this program with you. Okay, so I'm giving you, so you please read through this and understand its implementation. Okay, how it is implemented, how this program is written. Okay, this program is not a bad, it's not a large program. Okay, it is a small program. And then, so what is doing over here? So it is making two uppercase. That means it is whatever character you enter, either in uppercase or lowercase or mixed case, it is converting to uppercase letter. Okay, the string you are taking, and then here the main operation is here. Okay, so I'm giving the program, so it is simple. So please go through it and try to understand it, because it is uses built-in stack and QB, so operation is simple. Okay, we have one more lecture. We will go through SCAR or simulation in our next lecture, but today let us see the implementation of QE. Okay, so as similar to stack implementation, so we know that stack is implemented in two ways, using array type implementation, and another is linked list type implementation. So similar to a QE can be implemented in both ways. So it can be implemented using like an array, okay, or using a linked list. So here, so if you go through these steps, so please read the book chapter, okay, so then you will understand how these are simple. So let me give you some heads up so that you read this and you understand this clearly. So here in a, this is a QE, right? In QE both sides are open, okay, but all data enters from the right side. Data enters from the right side. This is enter, entry, and this is exit. Okay, so the first one, so here this is on the front, this is ready to go, but also it entered first in the QE, and this is on C. Okay, it is the last element. So until you remove A and B, the first two elements, since its position is third in the queue, it cannot be removed. Okay. So, for instance, if we remove first element or first two elements, A and B, for instance, here. So, and also if we enter two other elements, maybe C and D. So D and E. So then elements that will be entered, they will go on the back, but the elements that are removed, those will be removed from the front, right? So in that case, after you remove A and B, if you remove A and B, so that, for instance, let us think that A and B, these spaces are empty, okay, and this will be, C will be your first element, first or top element, okay. So then now the question is that how do we remove the first or some elements, okay. As we saw that at the beginning, a QE maintains two other link. One is called front or top, another is called bottom or rear. So give me 1 second, let me go to the beginning here. So one is front, one link from the front and another link from the rear, okay. So in case of an empty QE, both front and rear are none, right? And in case if there is only one element in a QE, then both front and rear, they indicate the same thing. Okay. Give me 1 second. Okay. So as we saw that a queue maintains two links, one for top or front, another for bottom or rear. So in regular array operation, for instance, we know that an array, it works with index, right? An array, all elements are associated with index. So in an array, if we want to pick up the third element, so then we will use index 2, right? But in stack or QE and QE, so how do we remove an element, okay, and from stack? What we do, as I said, that in linked list, we just unlink a node, okay. So here similarly in QE, we will move the top or front to back. So initially this was A, so that this was denoted as top or front. Then if we want to move A, then what we'll do, we will say move equal to front equal to just A, the node 1 dot next. Okay, node 1 dot next, or node with element A dot next. Then it will say A will be unlinked, and then B will be top. Similarly, if we want to move to both A and B, so then what we'll say, so then top will be top dot next, then it is got B, and if we say dot next, then again it will see that indicate the third node C. So this way actually we do not actually remove an element from the memory, just we unlink or delink an element from our QE. So here, now they come, so in QE, I would say in Q and DQ operations over here. QE1 template. Okay. So here, this program is for QE implementation with an array. So header file of the array version of the QE implementation. So you can copy this header, copy this program, and put in a program. And as we know that we put header file and then our CPP file in different files, then we'll see this. Let us do it as the definition. Let's see. Okay, this one, does it have main? Okay, it does not have main program, but you can implement it, and later you can use it in the main program. I don't like the word push or pop. This is constructor, they call pop. I would say DQ, and this is NQ. Font size empty, include QE dot template. QE on dot template is this one. I don't like this implementation, so that's QE, then push pop. I have book. So let's see an example. C plus plus. So it should have using linked list. Array. So array implementation is simple. So instead of the book, I don't like the word push and pop because it's confusing. So NQ, let us see here. So NQ is just enter an element or a node in a queue, and DQ is removing an element from the queue. Okay. So array implementation is like this. So for instance, this is an elements that you put in like in an array. So in array, elements are indexed, right? Index start with 0, 2, 0, 1, 2, 3, 4, 5, and the index 0 is front element. Okay, and for instance, if we think that the front element, this is memory space. This 500 over here is the memory address of the font element, the top element or index, with index 0, and maybe this one is the last element. Okay, and it means memory space, maybe something they put something 5020. So in whenever you run this program in your computer or my computer, it will come up in a different memory location, but for simplicity we can guess any memory address as something like this or like this. Okay, this is front and this is rear. So here how an insertion happens. An insertion happen at the end. Okay, so rear. Okay, and the rear position or bottom position, and an extraction, that means called DQ, happens at the front. So in order to do array operation, how do we do? We jump to the right location, right? To the with index. But here in a linked list or a QE, we need to go one by one. We cannot jump to anywhere. We need to from start or beginning position or front or top, and then we need to go on by one. Okay, and then in order to add an element in a QE, you must add at the bottom. You cannot add on the top or in the middle. Okay, so this is this. Let us copy this program and then let's see. So if you search in my Replit account, you will see that I have programs written in C++, Java, and C#. But this is not from Yeah, right. Okay, so you can put with stack or structure in a C++. Actually C structure is for mainly C, and C++ or C language has data structure is called struct. Okay, like class, something like class. Okay. Yeah. You can change it to class, then you need a few changes. For instance, over here, you need to make it I'll try. Let me run it. Okay. So this program QE you can implement with a class, or this is actually the QE, or you can implement with a node class, separating node and Q class. So whatever you do, there are multiple ways. So since it is array implementation, our goal is to understand linked list implementation mainly. So here, this is NQ operation. QE is NQ is fine, any name is given, and then this is DQ operation. So in the NQ operation, you enter an element, okay, and then whenever this NQ operation is very simple, like this, two lines actually. You insert a data, and the real value, whenever you insert a data in a QE, the real will go, real position will be increasing, right? So here, whenever you enter one data, so initially this was real, so then real go with the next one. Real value will go to the next one. So for array implementation, it is denoting a index, an index. So that index will be incremented by 1. Okay, so here this is why. So rear so capacity and rear for an empty QE, so front and rear, so this is 0, both 0. But if you add an element, then your, so initially that value will go to the 0th index, and then next index will be 1, right? So then in rear plus that means rear equal to rear plus 1. Okay, then that will be for the next element to enter, and then similarly, so this is for if capacity is rear. For instance, capacity is 0, initially rear equal to 0. Okay, so then that is maybe full, or actually if it is empty, then we'll do this way. And then DQ operation, removing an element from an element. Okay, if front equal to rear, that means Q is empty. So that Q is empty, so front equal to rear, that means initially we put front equal to rear equal to 0, right? So that means if there is no element in Q, that is Q is empty. Otherwise, what we do, since this is an array implementation, so we will go through index. So what is the index starting from? So I equal to 0, and I will go rear. So rear index, and then it will go 1 by 1 by 1. Okay. So here, one thing is remember that. So rear -1. Okay. So here what we'll do, what is doing over here. So for DQ operations, so what do we say? Let me try it. So this is your queue, right? This is front and this is bottom or rear. So how do you remove an element? So if you remove element, right, from this element you remove, right? So then what will happen? So then this element will go here. So in array implementation, that means we know that a memory space contains only one value at a single time. So this value will be overwritten. This previous value will be overwritten, right? So if you take this out, after that what will happen? So this one will come over here. This is why, and then this one will come over here, and this one will come over here. So this way. That is happening over here, shifting, moving. Okay, and then at the end, so rear, initially your rear was here. So if you move one element from the top, then your rear will be over here. This is why rear minus minus. But you add an element in a QE, then you do rear plus plus. Rear index will increase for addition, and rear index will decrease for deletion. Okay. Now the other operations are simple. This is display. Display means displaying each elements, and QE front, that is you are getting the front element. Okay, and this is main method. And since this is structure, is a new data type in C++. Java does not have the structure. Java and modern languages, and C++ also. So it is a little bit different. For instance, over here, there is structure elements. There are 4 elements. Okay. So you can do, that is 4. That means you can do 4 operations. Capacity is given is 4. Okay. So this is why you can give maximum 4 operations. If you want to give 5, it will not take. Okay, so this one is for stack. Let me see what this one. No, this one delete. Okay, this one is good. Array. Key array implementation. And let us make another example. QUE. Is better. They use node, different class. Okay, number choice 1, enter an element 34. Number display 2, it will display 34. The number 1, enter 20. 23. Enter your choice display 2. Oh, sorry, delete the element. 3 is display the element. Okay. Enter your choice 1, 2. Enter your choice 1. And insert element 1, 3, and then number 3 it will display. Okay. 4 exit. Okay, it is a good program. No. So now let us understand how this works. So it is a linked list implementation. So as we know that in linked list, so in a QE we need to maintain 2 links, 2 node type links, one for front, another for rear. So initially for an empty QE, both front and rear are nil. So this is why initially they put null. In C++ they put null. In some languages they put nil. Okay. And this is not temp, or you can say top or front, whatever you say. And this is insert. Insert is mean NQ operation. Okay. We can say NQ, ENQUE, NQ. So I need to change it here, NQ. And not delete DQE. This is standard word. DQE. So I need to change it here. Let me see it works. Okay, it works. So in the NQ operation, for instance here, so in array implementation, what did we do? We increased for insert operation. We increase the pointer, right? So rear pointer. We increase the rear pointer by 1. And here, but we will use array operator. It's minus and greater than together. So the array operator, that means rear dot next. Okay. So if rear is null, that means if it is in empty stack, empty QE, there is nothing element here. Okay, and then we say rear equal to this one is called here it is typecasting. It is called typecasting, changing one type to another type. Here what is doing, malloc is a useful method in C++. It is used for memory allocation. Okay, memory allocation, and you see that how it is used is size of, this is a built-in function of structs node, whatever node size it is. Okay, whatever you put data in a node, and then it allocates that amount of memory space. Okay, and then here then it says near dot null, near dot next equal to null. That means it goes to the next element and make it null for the next time insert operation. And that it says near dot, so for instance here it is putting data, whatever data you are inserting over here. You see that node, structs node, whatever it is doing, it is creating an object on the fly, and this node has a constructor. So the structure has built-in constructor within. So whatever data you will put, that data will go over here. And then for the next one, so react.next equal to null. For instance, that what will be happening over here. So for instance, initially your queue was null, empty. But whenever you put an element, this is the element whenever you put. So then rear will be the next one for next operation. So it is making ready for this. This says rear dot next equal to null. Initially, this is null. You are putting. So initially it was null, right? Initially this was null for an empty QB. This was null. But whenever you put an insert and data, so that means it will take the data in this position, and this position is here, and it will create another position, and initially that value will be null. Okay, and whatever data you put over here, that's the data react.data equal to value, whatever value you are putting. So the insert whatever value is seen operator going over here. And in that case, you see the front equal to rear. Okay. So here in that case, initially, when the stack was empty, then what was that? Front equal to null and rear equal to null. Okay. But whenever you put an element over here, right? So then that element will be front, and rear will go over here. Rear will go the next element, and but this one will be front. So this is why it says front equal to rear. So this is will be front. Front will be here, and then rear will be actually this one. Okay. Otherwise, this is another condition. Otherwise means that if the queue is not null, for instance, it has some element, existing elements. Okay, then what we say, we are making another temporary variable. You see that almost this operation is almost the same thing. It is allocating memory for the node. And here, what we need to do, this is a swapping operation. So rear.next equal to temp. So initially rear was here, then rear.next equal to this will be another next equal to temp. So this is temp over here, temp over here. And then temp.data equal to value. So I'm sorry. So rear was here. Rear.next equal to this one. Rear was here. So rear, this was rear. Not this. So rear dot next equal to temp. Okay. Rear dot next equal to temp. And temp dot data equal to value. Whatever rear dot next equal to, these will be temp. So here this will be temp, and in this position temp.temp, this arrow operator data equal to value, whatever value you put, this will go over here. And then temp.next equal to null. So this is your temp. So this is your temp. Temp.next. This is temp.next. This one will be null. So that means this space will be ready for the next occurrence of insertion. So this is, so then in that case, the null not no longer it will be null, previous value will put over here, and then this will be null. Okay. And rear will be temp, and in this case, so rear, okay, initially rear, previously rear was here, so then rear will be now here because that is the last element. However, there was one element or some element, this was rear, at this time rear will be the newly inserted element. Okay, does anyone has any question? Okay, I will take the attendance, and then DQ operation. Okay, DQ operation, if the queue is empty, underflow means the queue is empty. Queue is empty. If the queue is empty, then there is nothing to remove. Okay, and then if it is not empty, that means this is temp.next not equal to null. Okay, then it will say temp equal to temp.next, and then it is deleted, actually not deleted, actually it's DQ or removed. Okay, whatever you say. And you see that a free method, so it is used to whenever we use malloc method is used for inserting, allocating memory location, and free method is used to free up the memory location whenever some elements are deleted from memory space, so that element will, that memory space will be free for use. Okay, so this is here in this case, in case you have multiple elements. Okay, you have more than one element, that means temp dot next not equal to null if you have more than one element. So this is why one element will be removed and font will be temp. Font will be, this temp is temp dot next, right? Font elements, that means here, like here. Let me draw this. Sorry. Okay, so this is font, for instance, there are multiple elements. So whenever you say temp dot temp, this is arrow operator. So I'm used to say pronounce a dot. So okay, temp arrow next. That means in C++, in other languages use dot. So temp next not equal to null. That means if you have some elements, that means you will be removed from the top one, right? You cannot remove other elements from the top elements. So the temp will go temp dot next. So initially it will go over here. and then free this space, this is delinked, and then front will be temp. So initially it was temp over here. So by this statement, you are making this temp. This is your temp, and you are making this as your front. So that means this one is delinked. So this is front, then this one is delinked, and then this one is delinked. So it will not be associated with your link with your QE anymore. So then it's a front equal to temp. That means this one will next time for next world will know that this is your beginning of the QE. Okay. This is the situation if there are multiple elements, but in the situation if there is only one element in a QE, this is the only one element. So this is already front. This is front, and this is also rear. We know that if there is only one element in a, this is front and this is rear, right? So in that case, if you remove this element, so then what will happen? Front equal to null, rear equal to null. Okay, otherwise actually I could write this way. I could write this. This seems to me better. If you do this way, if you write this way, if temp.next equal to null, that means you understand this way. Else if. Okay, so this one, if front equal to null, is for empty QE, and if front.next equal to null, that means one element in the QE. If there are two or more elements in the QE, this will happen. This one. One, then display 3. If I remove 2. Okay, it works. So I'm giving it with this link. So please practice this program. Okay. And now we can follow the book, and you can do. They used here structure instead of structure. You can use class. You can use class. Okay. So there is a little difference. So what is structure is a kind of data type only used in only C++ I know, and C and C++ I used. I don't know other languages. Only languages do not have. But this is a good example. You can try with this. Okay. Now let us get the attendance. Does anyone has any question?
No questions.
Okay, so whichever days I take attendance, okay, I will give point based on my attendance. For instance, if I do not take attendance for some days, I will not consider that those. That is, but for instance, today is October 5th. Okay. Okay, can you please tell me your name from the, maybe it is sorted.
Hi, Jason's here.
Yeah, and Jason here.
Yes, that's me.
Okay, thank you.
Thank you.
What about Ashford, Matthew, Daniel, Myers,
Here.
Antonio
Myers, Barry.
Myers?
Yes, sir.
Yeah. Antonio Brewer here.
Yeah.
Yep.
Myers or Antonio?
Can I?
Let me see.
Hello.
Yes, I can hear you.
Okay.
Who are you?
Antonio Brewer.
Okay, Antonio. Who is Myers?
I'm here, sir. Myers, Barry.
Okay. Jasmine Brown, Taton, Elisa, Taylor,
I'm here.
Ernest,
I'm here.
Angel,
Here.
Jaden,
I'm here.
Cody, Cody is not here. Isaiah, Jimmy.
Someone said 9 is here.
Who? What is your name?
9. Line 9.
No, there's no line. Line number 9. Alisa?
Yeah, she said she was here in the chat.
Oh, okay. Yeah. Jimmy?
Here.
Jimmy's here. Sabi?
Here.
Lowell? Lowell, can you hear me?
They said they're here.
Okay, Lowell is here. Okay, Dave?
Here. Here.
Karen? Mikael?
Here.
Okay, thank you. Jazz? James?
Here.
Brandon?
Here.
Noah? Alan? Kenya?
Here.
Jimmy? Jimmy? Okay. Lilivia Taylor.
I'm here.
Okay, thank you. Jesus. Cameron. Sebastian. Alice.
Professor.
Alice?
Professor, can you hear me?
Yes. What is your name?
This is Sebastian. I'm here. My mic wasn't working at first.
Okay. That's good. Alice? Justin, Daniel, Andrew, Nicholas.
Nicholas here.
Nicholas here. Jessica,
Nicholas. Jati pe Jessica.
okay. Jessica,
Andrew's here too.
Andrew,
Yes.
okay. Jessica, 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
Line 33 is here.
17. Paris,
Typed in chat.
okay. Okay, so everybody please practice this program, okay? And then try to implement this using a class. Okay, there is some minor implementation. So then if you use class, then you don't need to use, maybe you don't need to use struct over here. So you may not need to use malloc or free function, because in C++ in class is an advanced data type that usually uses in class. When you declare a class, you will see that there is a destructor. The destructor automatically frees up memory space. Try to implement this in class, okay? Maybe the book has name class, but I don't like the name the book has. Fusion Power. Okay, does anyone has any other question? Okay, if you don't have any other question, let us wrap up today, and then thank you so much. And then you please read the announcement, and then please see our GTS if you need any help. Thank you so much.
Thank you.